We talked earlier in the previous lesson about parallel lines. Today we're going to talk about perpendicular lines. So two non-vertical lines, sorry about that. Two non-vertical lines are perpendicular if their slopes are opposite. That means the opposite sign. Reciprocals of each other. So that means if you have a slope and you want to find out what the perpendicular slope is, you should flip the fraction, switch what's on top and bottom, and change its sign. So if it was negative, make the new one positive. If it was positive, make the new one negative. And vertical lines and horizontal lines are perpendicular. Now they make this special mark because vertical lines have undefined slope. Horizontal lines have a slope of 0, and we can't really say those are opposite reciprocals. So, but they are perpendicular because the definition of perpendicular, you don't have to remember right now, is that it's two lines that form a right angle, which horizontal and horizontal and vertical lines do that. So let's walk through this first one with the steps just like we did on the parallel part. So we want to write an equation in slope-intercept form for a line that passes through, sorry I have to keep clearing my throat and know what's going on. It passes through this point and is perpendicular to this graph. So just like last time, we will need to start by finding the slope of this line, but instead of using the same slope, we will then find the opposite reciprocal. So we'll determine the slope of the line that is given. This is in standard form. So remember, we can use that trick for standard form. We do negative a over b, which makes it negative 2 over negative 3. And the negatives cancel, so we'll say the slope is 2/3. So the slope of the line given to us is 2/3. But since they're perpendicular, we need to use the opposite reciprocal of the slope to be the slope of the line we're creating. So we need to flip the fraction and change its sign. So positive 2/3 is perpendicular slope to negative 3/2. So you just flip the fraction and change the sign. So we're going to plug the new slope and given point into the point slope equation. So let's go ahead and do that. We have this ordered pair and this slope. So I can say y minus 6 is equal to negative 3/2 times x plus 1, because it's minus negative 1. Then we'll rewrite the equation into slope-intercept form. To do that, I need to distribute the negative 3/2. And then add 6 to both sides. So that's the same as negative 1.5, or you can say this is the same as adding 12/2. So negative 3 plus 12 is 9/2. So we'll use that same method on these four down here. So write an equation in slope-intercept form for the line that passes through the given point and is perpendicular. So perpendicular, you got to think opposite reciprocal slopes. Or if you just want to think flip it and change the sign, that's fine too. So this one has a slope of 1/2. The opposite reciprocal of that is 2 over 1, and we make it negative. And you can certainly just write that as negative 2. So our slope of the perpendicular line is negative 2. Our point is 4/2. Y minus 2 equals negative 2 times x minus 4. So I plug the ordered pair and the slope into the slope-intercept form. Point slope form. Then I'll distribute the negative 2. and add 2 to both sides, giving us y equals negative 2x plus 10. Okay, we'll follow the same pattern over here with number 2. The slope of this line is negative 2/3. So we've got to flip that upside down, make it 3/2, and we make it positive because we got to change the sign. So this one, the original was positive, so the perpendicular was negative. This one, the original was negative, so the perpendicular one is positive. So this is our slope of our new line, and there's our ordered pair. So we would do y plus 3 equals 3/2 times x minus 2. Now that we've gotten it in point slope form, let's see if we can now get it in slope intercept form. So I'll distribute 3/2. 3 times 2 is 6. 6 divided by 2 is 3. Then our last step is to subtract 3 from both sides. So you get y equals 3/2 x minus 6. Okay, number 3. The slope of this line is negative 3. And you might understandably say, wait a minute, how do I flip that over? That's not a fraction. That's true, but you can make any whole number a fraction by putting it over 1. So once we've made this into a fraction, we flip it over, we make it 1/3, and we make it positive because we've got to make it opposite of this one, which is negative. So the slope we'll use is 1/3, and there's our ordered pair. I'll plug that in the point slope form. Then I'll distribute the 1/3. Subtract 2 from both sides. We've got our answer. Okay, last one on this side. We have a slope of this line is negative 1, which we can make it into a fraction by putting it over 1. Well, when you flip 1 over 1 upside down, it's still 1 over 1, and we change it to positive because we have to do an opposite sign. So our slope of our perpendicular line is positive 1. So we'll do y plus 7 equals 1 times x plus 8. Distributing the 1 doesn't change anything. We just can write x plus 8. Then to get the y by itself, we subtract 7 from both sides. We get y equals x plus 1. Okay, we're going to do a few on the back as well, because now that we know both parallel and perpendicular, there's one more skill they want us to know, and that's to compare two lines and figure out, are these two lines parallel, are they perpendicular, or are they neither? So to do this, we'll have to figure out the slope of each line. If the slopes are the same, then the two lines are parallel. If the slopes are opposite reciprocals of each other, then they're perpendicular to each other. If they're not related in either of those two ways, then they're neither. So you're looking for ones that are the same, ones that are opposite reciprocal, and if they're not those two, they're neither. And just a reminder about the trick with standard form, you can find the slope by doing negative a over b. So this is actually a little quicker, to be honest, than the ones in the front, as long as you are careful about finding your slope. So both of these on number 5 are in standard form. So for the top equation, I can do negative a over b. So I make the 2 negative, and there's the understood 1 in front of the y, that's my b. Down here, we have a slope. There's the understood 1, so we make that negative 1 over negative 2, which reduces to 1/2. So you notice these are the reciprocal of each other, 2 over 1, 1 over 2, and their signs are opposite. So that tells us these two lines are perpendicular. Okay, on number 6, the first one's in standard form, so we can use the negative a over b trick. So we do negative 4 over negative 1, which is positive 4. And I'm just keeping it in fraction form because that way it'll be easier to see if the result is flipped or not. Now this one's not in standard form. It may look kind of like that, but the x and y are not on the same side. So you could put this in standard form and check out the slope. That's fine. Personally, since y is already in a term by itself, I would just divide everything by 4. And look at this slope right here. Because this is in slope-intercept form, and that was pretty low effort to get to that. So this one has a slope of 1/2. Well, these two are definitely not the same, but they're also not reciprocals or the opposite side of each other. So since they don't have either of those two relationships of being the same or opposite reciprocals, I just have to say those are neither. They're not perpendicular and they're not parallel. Number 7 is similar. The top one is in standard form, so I can do negative a over b. 6 is the a, negative 2 is the b. That reduces to 3 over 1. This one, I'm going to do the same thing I did back here on 6, and since it's already got y over by itself, I'll just divide everything by 3 to put it in slope-intercept form. And so I can see the slope is 3. So they both have the same slope. And when the slope's the same, that means the two lines are parallel. Okay, this is a horizontal line. Y equals 5, y equals any number. That's a horizontal line, slope of 0. X equals a number is a vertical line. That slope is undefined. Okay, so we can't compare them the way we normally do because it's 0 and undefined. But that's where you got to remember the fact we learned up here. Vertical lines and horizontal lines are always perpendicular to each other. So since we have a horizontal line and a vertical line, it means it looks like this and this. So they are perpendicular to each other.